We can have a discussion on multiple topics, but today we'll be discussing a bit more about the privacy. So first of all, yeah, first of all, I'll discuss basics of blockchain, that what are the types and what are the different functions, different layers, applications, and motivation, like why we should be using blockchain. Then afterwards, I'll discuss about the privacy and its solution, like what exactly is privacy. Like people normally you can say, confuse security and privacy as a similar thing. So what are the differences and what are the basics of privacy? Then I'll discuss about certain privacy challenges in blockchain and like what are the privacy attacks, such some issues and concerns, then some privacy preserving solutions and what we are doing or what our group is doing. So first of all, what exactly is blockchain? Blockchain is basically an encryptable ledger. Let's say traditionally, whenever we want to make any transaction, we used to have a ledger, and the person who is in charge of that ledger used to update it. But now everything is digital, and the blockchain can be termed as a digital ledger, which is encryptable, and everyone has a copy of that ledger. So one of the famous example is Bitcoin or Ethereum. And what are the benefits? Such as blockchain provides a transparent log, so every participant of the ledger has a copy. So nobody can modify this. Let's say if I want to modify just a slight piece of information, it will change everywhere, like on every node. So because it's transparent, everyone will be able to watch it, that what exactly has changed. Then there's secure transaction, like nobody can mine or change anything on blockchain randomly. Like you need to follow a standard procedure of consensus in order to ensure that the transaction has been recorded. Then it is a decentralized network because every node has a copy, all of the nodes has control. So it's a decentralized network. Then it is peer-to-peer communication. Like if some node makes any change, then it has to disseminate everything to the other nodes, and this is how it works. Like the communication will be from each peer to peer, and that's how the communication works. Not like if even if you are broadcasting something, you are broadcasting in a peer to peer manner. Then it is timestamped, like every change or every transaction on the blockchain network or the blockchain ledger is recorded with a timestamp. So you cannot modify the time of any transaction. Then it is easy backtracking because everyone has a copy, and nothing can be hidden from the ledger. So it's easy to backtrack the blockchain transactions. Then there are three basic types of blockchain from the perspective of you can say implementation, or you can say the control. First one is public blockchain, in which like every individual can join, every individual has a copy, and everyone has a right to mine and do transactions in the blockchain. So this is the common network that we usually have in Bitcoin and in Ethereum, in multiple cryptocurrencies. So this is public blockchain. Then there's private blockchain, which is basically a permission blockchain, or you can say a decentralized network in which some controlling authorities have control over the data, and they can basically define the rules, what they want to show to the other nodes who are not in control, like who are not in the controlling authority. So they can modify these things in a way that whether these nodes will have a power to do some changes in the blockchain or blockchain network or not. So it depends upon like a specific group of people. They have the control and they can define the rules of the network. Then there's consortium blockchain, where multiple public and private network, like they merge in a way that they form a consortium. For example, like if different companies do a merger, let's say there are two major companies here. There are, let's say, Telstra or Vodafone. Like they start doing a merger of some of their technology, and they move their data to blockchain. So that could be a consortium blockchain. So both of them are defining rules. So these are the three major type of networks or types of blockchain. Then apart from this, the working phenomena. So if you look into this diagram, so first block of blockchain is the genesis block. So there's nothing, just the data. So there's nothing else apart from the data. Genesis block is usually hard coded. whenever you try to start a new blockchain network or a blockchain ledger, you form a genesis block and all the blocks are formed afterwards. So the first one is the genesis block, and afterwards Genesis block will have a header, and the next block will have a header of Genesis block as a pointer to the next block. So this is how, and then the hash of that specific block is computed and it is also stored in the data, like in the form of the block. So all blocks are linked with each other. So how we compute the hash, like we can say gather all the information within of all the data, all the hashes, all the timestamp data, everything that needs to be in the block. We use different phenomena such as Merkle tree or certain other hashing phenomena, SHA-256, and you use them and compute a hash of a block, and then that hash is stored as a header, and that will be the part of the block. So if we change even a full stop in because we are computing the hashes via SHA-256 like secure hashing algorithm. So if we change just a little bit, even a full stop within the previous block, the hash will change. So the blocks afterwards will not be consistent anymore. So nobody can play with the blockchain and change anything over here. Then one of another important phenomena in the blockchain is the consensus mechanism. Like because blockchain do not rely on the third party, like you do not need a centralized authority to control the transaction or the blocks in the blockchain. So in order to validate the transaction, we need certain consensus model such as proof of work, proof of stake, delegated proof of stake, practical Byzantine fault tolerance. So all these are different consensus models. They are basically used to ensure that the whole network has reached consensus. Let's say in the proof of work, what we do, the mining nodes usually solve a computational puzzle, and when they solve that up, they show that okay, we have solved this specific puzzle, and once it's done, he will have the right to mine the block in the network. Otherwise, he cannot mine the block, and the uh, you can say a difficulty of the puzzle is defined in a way that there will be only one block per 10 minutes. So the if there is more computational power, they will make the puzzle a bit more complex, a bit more hard to solve. So this is how the consensus mechanism works. Similarly, in the proof of stake, the node which has the maximum stake in the network will be chosen as the consensus like winner. Definitely, there are certain other sub aspects of this as well. So these are some of the famous mechanisms of consensus mechanisms. Then there are transactions in the blockchain network. Transaction like basically serve as the purpose of like whatever you are going to store, whatever you're going to share in the network. So these are transactions. It's not necessarily they should be a financial transaction. This could be anything. Like you can store an image, you can store a video, you can store anything that could be that will be termed as a transaction. Then afterwards, um, there are multiple layers of blockchain. Um, People have defined 4 layer, 5 layer, 6 layer. So you'll find multiple, you can say, architectures in different papers, but you can say most of these paper, like you can say more than 50% use this specific architecture where there are 6 layers. The first one or the highest layer is the application layer, which basically we use in the form of like business application, IoT application, or which is a practical interface that normally all the people see on their end. Then there's contract layer, which is basically let's say if you are using, if someone has designed an application, blockchain based application or dev for you, decentralized application for you, he might will just give you some hard coded smart contract that you can use. Let's say if you want to make a new transaction, use this smart contract. If you want to change anything, if you want to remove ownership, use this specific smart contract. But at the back end of the smart contract, there is programmability, so you can program and design any algorithm in a smart contract. Let's say if you want to design your smart grid network on Hyperledger Fabric, you can design it accordingly. Like you can provide all the functionalities that you want in your network in the smart contract, and when once it is executed, you cannot stop it. So this is the basic feature of the smart contract. So and all the things that deals with the smart contract is called contract layer, like so all the scripts, algorithms, contracts, and all these programmable features. Then there's incentive layer. Basically this is the major driving force of behind the blockchain network, that all the economic or financial things are involved in this incentive layer. Let's say if someone gets an ability to mine a block, or if someone solves a computational puzzle, how much reward should be given to that specific node. So all these things are defined in the incentive layer. Then there's consensus
Dr.
layer. Sorry, yeah.
Yeah, sorry, there's a question like in
Yeah, sure,
the
sure.
chat.
Okay, I need to.
Yeah, which layers are mutable versus immutable?
Because I've heard of talking about contracts wherein there's errors in the contract, and once the errors are there, they're permanent errors in the smart contract, and that's kind of a result of a lot of the security issues. So I'm just wondering, where does it get into you have to do it right the first time with these layers?
Yeah, the blockchain is immutable. So usually the blockchains are not mutable. You cannot change anything on the blockchain. It does not depend upon the layers. Once you execute the smart contract, it will be executed. You even cannot stop the smart contract once all the conditions for the smart contract gets fulfilled. Let's say you make a smart contract for, let's say, if John reached 55, transfer $50,000 from his account to his son's account. So once this condition meets, you cannot stop the smart contract. So these things are not mutable; these are immutable. But there are certain solutions which people are now designing to make the blockchain mutable, to make it more compliant to certain privacy regulations. But usually, on a whole picture or in a general picture, blockchain is immutable. It depending upon each layer, like each layer is immutable. Okay, perfect. So yeah, I'll move to the next slide. Okay, then the next one is the consensus layer, like which consists of various consensus mechanisms, like as I discussed in the previous slide, like proof of stake, proof of work, delegated proof of stake, and proof of energy, proof of elapsed time. So these are all the consensus mechanisms which are basically used to ensure that the transaction which is being recorded on the blockchain is legit, and on all the nodes have the same copy of the ledger. Like if the consensus is not uniform, there is a possibility that some node has a different copy, some node has a different copy. So consensus layer basically ensures that all the nodes has same copy. Then there's network layer. Network layer basically different networking mechanism, that how the blockchain nodes will be communicating with each other. What is the communication mechanism, what are the data verification mechanism, what are the different security mechanism in the communication will be used. So all these things comprise of the network layer, let's say like the peer-to-peer network, like all the verification mechanisms. Then there is data layer. Everything that is in the blocks in the form of a timestamp data will be regarded as a data layer, like each block, all the transaction in the block, and they are basically changed in the form of a ledger that I've previously discussed, that how the hashes are linked with each other. So it has got Merkle tree. Merkle tree is basically like you start computing hash from the bottom, and then you start combining these hashes with the hash function, and then at the end you have a unified hash for the whole block. Then the certain applications of blockchain. These are some of the daily life applications, such as a smart grid. Like blockchain provides a feature, or you can say functionalities of machine to machine interaction for the smart grid. Let's say there's energy marketplace, there are microgrids, there are prosumer, there are consumer, there's you can say certain other elements involved in a smart grid network. They can communicate with each other, establish a connection, establish a marketplace, and they can easily trade with each other in the form of with the help of smart contracts in a very autonomous way, and they do not need much involvement of a centralized authority. Then there's electric vehicles like blockchain-based EVs. There's you can say a large number of articles in this specific domain. A number of people are working in this domain, but usually some of the prominent works involve like scheduling, like scheduling of electric vehicles, that which vehicle should be you can say filling their battery at that specific time. So all this scheduling are being done by blockchain to ensure there's transparency, to ensure there's trust, to ensure there's no tamper proofness, and then the billing and the energy trading and all these things of all these functionalities of electric vehicle are being done by a blockchain, and there are plenty of articles over this. Then there's blockchain based healthcare. This is basically to ensure that the health record that are being shared with the doctor or with the authorities, it's you can say tamper proof, so nobody will be able to change it up. And it's because you can execute smart contracts in a way that it keep on recording according or in an autonomous way, so you can design certain smart contract for certain specific application of blockchain. Let's say for in order to manage and share health records for the medical supply chain. In the case of, let's say, in medical supply chain, you need to make sure that the medicine that you have received is you can say formulated on a specific time, and it is being stored in a specific temperature. So all these things can be recorded on a blockchain network, and all the participants involved in this tracking can see anytime that at this specific instant this medicine was there, and nobody can play with this or nobody can modify this. Then there's like medical professional and training and education, and then there's clinical research as well in the healthcare. Sorry. Then from the perspective of finance, we all know about cryptocurrencies and like the payment stream. It's becoming more common nowadays. Blockchain is more fast and secure in order to ensure that nobody will be able to cheat once a transaction gets recorded. So it's playing a very major role in finance. Then the real estate. Previously we used to have ledgers for the real estate, like you need to have property document that you own this specific house or you own this specific building. But these things can be done in a decentralized manner. Let's say there's a ledger for the whole city or the whole town or whole the suburb, and whenever someone buys a new house, they can make modifications in the ledger, and there'll be we can say nobody will be able to change it once it's recorded. So like nobody can do any fraudulent transaction, or nobody can do any fraudulent misinterpretation that this house was mine, or like nobody can change the things on the ledger. Then there's forecasting, like it depends upon how you are integrating blockchain with deep learning and machine learning and AI models in order to ensure various like forecasting model. Forecasting could be for anything, like forecasting for smart grid, forecasting for electric vehicle, healthcare. So it basically depends which specific model you are using and what's your specific application. Then there is supply chain. I've discussed a bit about the medical supply chain above, but it's similar. Like you basically bypass the intermediaries, and whenever someone receives a specific, you can say, data or any product, they can record that okay, we have received this, and nobody can change this up that I've never received it, or I only held this for 1 minute. So whenever you receive and you dispatch, you can record it on the ledger, and everything is timestamped. So these are some of the major applications of blockchain, or why we should be using blockchain. Then because all these things are being done on in a public ledger. Let's say all the nodes have copy, and everything is, you can say, tamper proof. You cannot modify anything but what is recorded on the blockchain. So there are certain aspects. Let's say the major thing is the privacy. So if everything is public, so everyone will be able to see what's happening on the ledger. So this thing raises certain privacy flags, that let's say if your data of your smart grid or smart meter gets recorded in blockchain, and everyone will be able to see when you are at home and you are using something, and when the home is not occupied. So you don't want to share these data, or don't want to share the exact information. Let's say there are certain non-intrusive load monitoring methods by which you can just put your electrical records over there, and they'll be able to judge whether you are using toaster, you are using washing machine, or you are using any other appliance, and they can even judge that a specific appliance is not functioning up to its 100% capacity, and you might need to replace it very soon. So in such cases, you don't want to share everything with public on the blockchain ledger. So there arises some privacy issues, which we'll be discussing afterwards. But just a basic introduction of privacy. That what exactly is privacy? So the concept of privacy is not new. It can be mentioned as a right to be left alone, and it's also termed as a secrecy by an American jurist, that it is the right of the people to conceal what information they want about themselves, like whatever they don't want to share, they should have a right to conceal it. So some of the information types, it could be on information on internet, your financial information, political preferences, electricity, educational preferences, identifiers, healthcare, locational information, contact information. So these are all different type of information that comes under PIIs. We normally call it personally identifiable informations. Then there is Fair Information Practice Law by US in 1970, that whatever data you are collecting, they should be a predefined purpose, and information should not be disclosed to other organizations unless it is authorized by the law. So let's say if you have recorded some information on Facebook, it should not be disclosed to other individual or organizations unless it is authorized by law. Similarly, the record should be accurate, so nobody should be modifying the records that have been stored. Let's say you have stored something on a notepad online, and so nobody has a right to change your information because you have stored that. You have the right. So similarly, this is the last part is right to be forgotten. So if you want to remove your information, you should have a right to be forgotten. So these are some of the things that you can say are a little bit hurdle if we start implementing blockchain in a public manner. So because they can cause privacy issues. So in order to overcome this, there are certain privacy preserving models has been designed, such as static and synthetic anonymization. So where you basically remove PIIs in a way that the data becomes anonymous, and the organization who is just going to carry out their analysis on analytics from this big data, they'll be able to do it without getting into the personally identifiable information. Then there's encryption, such as homomorphic encryption, like which allows participant to carry out computation without revealing the original data. Then there's swapping, like people like SDS swap, where data swapping is performed in the dataset to say ensure that nobody will be able to judge which specific data type belong to which specific individual. Let's say you have a data of health records of 100 participants, and health record, let's say the blood sugar level. So they basically try to change the data or swap the data of individuals, so nobody will be able to get. Let's say you change the data of John with Bob, so nobody will be able to identify that whether this specific data belong to John or it belongs to anyone else. So this is data swapping. Then there's data perturbation, which is basically like we add a calculated amount of noise in the data to ensure that data is still useful, but it should not reveal the actual privacy. So these are some of the types of privacy. Then coming back to the blockchain, some of the famous privacy attacks, or you can say cybersecurity attacks, are the address reuse. Like public addresses are reused in a manner that adversary try to successfully link their addresses with the original identity, and they try to backtrack each and every transaction. Let's say if this specific person has done this much number of transactions, so it's possible to track back in public blockchain network, or the public databases of Bitcoin or different blockchain cryptocurrencies. Then there's the anonymization attack using graph, like different public addresses are generated and their graphical illustration is carried out to find out the flow of transaction, to find out the relationship between different peers and different inputs and outputs. Let's say we form a graph and see this transaction, this person is carrying out a large number of transactions between these two people are carrying out a large number of transactions between among each other. So they might be linked in some way, they might be friends. So this is called de-anonymization using graphs. Then there's wallet privacy leakage, that blockchain wallets like they were introduced to ensure the overcome the address use attack. So every time like you use your blockchain wallet, different addresses are generated and they are exchanged in that manner. However, people try to get into this specific information and like to leak the transactional privacy. Then there's cyber attacks. Some people try to fake other users. This is also known as 51% attack, and this is also, yeah, cyber attack is usually used when you have 51% of the computational power of the whole network. Then there is message spoofing attack. Then attacker tries to disseminate fake messages by broadcasting in the network in order to reduce the safety concerns, security concerns, efficiency. And this can lead to dishonest messages, and it can be embedded as false information in the network. Then there's linking attack, that the external data is linked with some other data. Let's say you have a database of Bitcoin transactions for a specific region or for a specific area, and then you pick an other database for that specific area and try to make a link with each other, because certain transactions on the blockchain networks are pseudonymized, like they are not completely anonymized, they are not completely public, but there are pseudonyms that can be used to identify. So people try to use this specific in multiple data set, they try to combine and do linking attack. That let's say this person was using a specific, has a database of website visited and then a database of transaction. So if someone is using a specific wallet, or you can say cryptocurrency website in a specific time, and then there's a specific transaction at a very that instant of time, so they'll be able to link, okay, this person, this pseudonym belongs to this specific person. So these are some of the linking attacks. Then there are crypto checking attack, like which is a form of attack, you can say, to illegally perform the consensus or proof of work. Like you try to steal or cryptojack someone else computational power, because proof of work, let's say, require a computational power. So you basically try to illegally steal the computational power of someone without others' consent. So this basically result in mining process become more expensive. So in order to overcome this, they will increase the difficulty, they will ban specific nodes, but this will cause the mining process a bit more complex. Then there's like exploitation of network information. Let's say they tried, man in the middle attack is one of the this specific type of attack. Like they try to intercept the transaction in order to reduce the anonymity, that which specific case belong to this specific person. Then each layer has different challenges. Let's say from the perspective of application layer, we have end users, and we have privacy in we need privacy in the end user application and in the development platforms. This can lead to user identity privacy leakage. Let's say if someone find out who is using a specific app in a specific time, so this leads to user identity privacy. Then in the contract layer, we have got chain code, smart contracts, certain other type of coding functionalities. So there could be a privacy leakage in certain conditional smart contract. Let's say if there's a smart contract that I previously discussed, that if John reached 50 years, give $10,000 to his son. So this basically this condition leaks privacy, that John is now 50 years old. So there could be certain conditions in a way that you can preserve the privacy. This can lead to identity privacy leakage. This can lead to like certain other privacy issues. Then there's incentive layer, like how much mining reward is being given to a specific person or specific node. This leads to transactional privacy. Then there's user identity privacy as well, and like which specific node is receiving a specific amount. So multiple privacy aspects can be linked with this. Then there is consensus layer privacy, that who is being selected as a miner, because let's say in the proof of work or Bitcoin, the mining reward is pretty high, like a number of Bitcoin. So nobody wants to share that they have this specific number of Bitcoins. So this can lead to like the identity privacy leakage, and then the consensus privacy and transactional privacy leakage. Then there in the network layer, if there's some man in the middle attacks and someone start hearing the conversation, or the conversation started get broadcasting to other nodes, because there's a broad broadcasting phenomena in blockchain network. So this can lead to certain other features of privacy leakage in the blockchain. Then there's data layer. In the data layer, like how information is stored, this can be linked to a certain privacy issue that I've discussed earlier, like such as transactional privacy leakage, identity privacy leakage, ledger data transparency, and all these things. Then discussing each of the privacy concern in a bit more detail. In the transactional privacy, if we say that we have to maintain that the ledger is uniform, so nobody should have a right, nobody can modify what is being recorded. What once it's recorded on the ledger, nobody will be able to modify this. So this is, the ledger is always uniform, but this information can be misused in a manner that they can backtrack things, and there's a transactional privacy leakage, that people can backtrack which specific node carried out which specific transaction, and like how much we can say Bitcoins have been transferred from Bob to John. So these things can be analyzed by using simple graphical techniques or simple linking or attacking mechanisms. Then there's user identity privacy. So apart from just linking, or you can say getting information about the transaction, you can link the pseudonyms of the nodes and find out which specific person is doing all these transactions. So you can even backtrack. And there's a news few months back that some of the bitcoins from the founder of some of the bitcoins from the wallet of the founder of Bitcoin has been from Satoshi's wallet has been used. So and this again raises certain question, that where is Satoshi and where is the founder of Bitcoin. So you can basically backtrack, and you can figure out that who is using or who is like changing things. Then there's ledger transparency, because the network wide data is transparent, and it can cause privacy issues via certain linking attacks. Then there is data and user privacy in malicious smart contracts, because not everyone has a detailed knowledge of coding, and not everyone can understand that what exactly is written in a smart contract. People try to uh, you can say lay down honeypots in the smart contract to find out various private information from the users. There's a very good article over this, exploiting honeypots in Ethereum smart contracts. So they have taken a large number of deployed smart contracts in the Ethereum network, and then they identified what are the loopholes and what were the honeypots that people fell prey of while running these smart contracts, and they did not knew that. So people try to leak others' privacy or get infer into others' private information via these malicious smart contracts. Then there's privacy in the consensus mechanism, because consensus is like it unites all the blockchain nodes on a single point. So but it is also vulnerable to certain attacks, such as like linking attacks, cyber attack, and the information can be backtracked, and nobody wants to share that they want this specific consensus mining ability at a specific time. Then there's privacy in blockchain channels. Channels is a new paradigm in blockchain, like communication. Let's say if you want to communicate, if you have a smart city on a blockchain network, and there is some emergency message that you want to disseminate about some, let's say, fire truck, or you want to disseminate about like a specific emergency in a specific house. Let's say a medical emergency. So you should not be using your traditional communication channel. You should be using the predefined channel for the emergency. So there are multiple blockchain channels. Hyperledger Hyperledger Fabric provides this facility of blockchain channels, but this can also leak privacy according to the application. So, like there are certain privacy issues in blockchain channels as well. So these are, you can say, some of the possible solutions. One is mixing, like combining and merging different transactions to hide identity. Let's say if one person A wants to send 50 bitcoins to person B, instead of sending it to directly to person B, there are certain mixing techniques that they send from A to C, 10 bitcoin, then A to D, 5 bitcoins, and then they combine and mix these things in a way that the end result is from A to B 50 bitcoins. So they are mixed in a certain manner that nobody will be able to backtrack that A sent 50 bitcoins to the person B. So they do not form a relation. Definitely, there are certain machine learning model or AI model that if they are used in a specific manner, they can backtrack things. However, this mixing techniques works pretty good in a large number of scenarios. That if you increase the number of nodes between them, number of transactions, so nobody will be able to identify the relation of A and B. So because it seems a completely genuine transaction. The second one is encryption, like use of public and private keys. It's already there in blockchain. However, in order to ensure that if someone wants to carry out data analytics on the blockchain network, they should be able to do it without the leakage of privacy. People try to use homomorphic encryption so that the information does not get leaked. Then there's anonymization, like removal of personally identifiable information before publishing or transmission of data. This is a bit hard in blockchain. However, there are certain works that have done this specific model, like anonymization, that they either store everything on the blockchain, and then at the time of and data analyzation, let's say if Facebook has stored everything on their network, and some other organization wants to learn something from their data analytics, like carry out their various analysis tasks on the data of Facebook. So what they basically do, they try to and remove identifiable information by the basis of first, Facebook is not doing this. Just giving an example that they can remove certain information with the help of smart contracts that this information should not be shared. So this is basically anonymization, or they try to make us you can say protected data set from the original data set to ensure that even if someone get into this protected data set or anonymized data set, they will not be able to get into the private information of the users. Then there are private contracts that I've discussed with anonymization as well. The programmable features are used in a way that the transactions, or you can say the details, gets anonymized. Sorry. Then there is differential privacy, like you add the noise in the data or perturb the data in a way that it becomes indistinguishable. Like this can be done in at the time of recording of the transaction. This can also be done at the time of analysis via smart contract. Then and there are certain solutions. One encryption that these are basically the one that I've discussed earlier. Just giving a bit more overview about all these. For the encryption, it basically works from the perspective of public and private keys, and it can be used to overcome message spoofing attack and statistical data analysis attack. Like if someone is analyzing these things, or there's some man in the middle, so you can enhance your encryption, or you can say some encryption capabilities to modify to ensure that there's no privacy attack. So some works that I've done use this thing is like vehicular blockchain networks and variable blockchain network. There are some works that have done these that have proposed the solution for these applications. Then there are private smart contract. The execution of smart contract on off chain and on chain data is another good direction in the private smart contract. Then it is used to overcome the anonymization attack and the message spoofing attack. Then it is used in currently being used in financial networks and vehicular networks. Then anonymization that I discussed earlier, that the removal of PIIs. Zero knowledge proof is also one of the subtype of this anonymization model, and it is also a trending research area nowadays. And it is being used in finances, electronic health records, energy systems, and it can be used to overcome the double spending and cyber attack. Then there's differential privacy, like how you perturb the data, how much amount of noise you add in the data to ensure the data that the data is still useful, and um, it does not leaks privacy as well. Differential privacy provides a very strong theoretical guarantees of privacy, which ensures that the blockchain network remains secure. Then there's coin mixing, that I discussed, that if A wants to do transaction to B, they basically add a lot of intermediaries among them. So these are some of the possible solutions that can be done in the blockchain, and people are doing this. There are certain applications till date. Then for the each layer, because my major focus was on differential privacy, so we have previously worked over this specific phenomena, that how differential privacy can play its role up to for each specific layer. Definitely there are certain limitations and everything cannot be applied to everywhere. However, there are certain subtypes that can be certain phenomena of differential privacy that can be applied to different layers to protect different type of privacy. For example, in the application layer, you can protect the end user's privacy by using a different type of perturbed identifiers, which introduces the randomness. So nobody will be able to guess that a specific person was doing or using this specific app at a specific time. In the contract layer, differentially private smart contracts is a large, you can say, hundreds of work are doing this. Like there are a certain number of work that have used differential pricing in various smart contracts to reduce randomness in a way, and that data analysis is good, and smart contracts are built in a differentially private manner. Then there's incentive layer. Instead of sharing the exact incentive that a person got, or instead of making it too obvious that this person got this specific amount of incentive because of this specific reason, you can introduce randomness in this incentive design phenomena. Let's say for energy auction, there's a phenomena that the highest bidder wins the auction, but how much incentive he'll be getting, it basically depends upon his bid, but he don't want to reveal his actual amount of bid for the for that specific auction. So the incentive can be randomized and nobody will be able to guess that this person was bidding this specific amount. So this can be done. Then in the consensus layer, the miner can be chosen in a differentially private manner. Let's say there's proof of work, proof of stake, proof practical Byzantine fault tolerance. So let's say in the proof of stake, you choose a miner on the basis of the maximum stake. But if you do it in a differentially and if a miner is being chosen again and again and again, you will be able to make a pattern. Okay, this person must have the highest stake in the network. So but if you do it in a differentially private manner, nobody will be able to guess that this person got chosen because he had the highest stake, or it's just in the private manner. So this is how you integrate differential privacy in the consensus layer. Then in the network layer is like privacy preserving communication technologies and anonymous communication. So this is being done nowadays. In the data layer, like how you randomize all the hashing phenomena, how you randomize all the transaction being recorded on the blockchain network. So this can be done in a randomized storage manner. Then there are certain solutions on top of blockchain. Like people are saying that okay, if there's a blockchain network already deployed, we can design certain privacy solutions on top of blockchain, such as this parent, like which instead of ledger based transaction, they worked over off-chain transactions. So the virtual payments can be done in an off-chain transaction, and then payment channels can be introduced to handle all these transactions, and then immutability can be used for certain specific required tasks, not for everything. So they basically merged on-chain and off-chain things. Then there are like bulletproof, like non-interactive zero knowledge proofs on top of blockchain, like to ensure the privacy, confidentiality. It basically enhances the multi-party computation, like SMPC, secure multi-party computation. That how you can compute on a data without risking its privacy. Then there's retractable blockchain that we have discussed earlier in the discussion, that how we can change the architecture of blockchain to make it mutable. Definitely it does not go 100% with the basic rule of blockchain that nothing is mutable, but in order to ensure certain privacy regulation, this is required at certain stages. So these are the three some on top solutions. What we are doing, like one of the thing that we are doing is like we are basically solving the privacy issues in smart grid or smart metering. That the previous works, if you get a fine grained data of a smart metering data, smart meter, you'll be able to identify that which specific home is using a specific amount of specific appliance at a specific time. So you basically can do a targeted advertisement, and even if there's some adversary or some malicious person, they can even plan some illegal activity, that this house is not occupied at a specific time, so we can um, carry out some illegal activity at that time. So we are basically working over integration of differential privacy. We have already have some works published in this direction as well. We are basically working over development of differential privacy in a decentralized smart grid network or smart metering network, like to preserve the daily privacy routines, to ensure that no intermittent value gets leaked. So these are some of the works that we are doing. Then from the perspective of privacy preserving blockchain auction, that how there are different type of auction. If we start studying the auctions in smart grid, one of the common auction is VCG auction, Vickery Clark Grove auction, where the highest bidder wins, but he pays the price uh, mm, equal to the harm that it has caused to the whole network. So nobody wants to reveal their original bid. So this can be so. But if you have the final price, final decided price or the hammer price in the auction, one can compute that what was the actual bid of this specific buyer. So we worked over designing a differentially private model to protect this specific auction, this specific type of auction, VCG auction, um, in a way that even if someone gets the final price of the, like you can say, final selling price of the energy in the energy market, they'll not be able to find out what was the bid, because we have selected it in a randomized manner rather than a static manner. Then there's privacy in blockchain-based healthcare IoT. That healthcare IoT is like people are trying to share their information in a decentralized manner with their, we can say, GPs or with their hospitals, but this can lead to the leakage of privacy. So we are basically working over designing of certain privacy preserving model using differential privacy, using zero knowledge proofs, using certain other and you can say privacy preserving tools to ensure that the privacy does not get leaked with the healthcare systems. Then we are working over the supply chain thing, like let's say if a supplier starts a smart contract, that we have started this delivery process. So every participant, trucker, or the person who is taking the freight to the supplier, to the buyer, everything is being recorded on the blockchain network. So this definitely is good for the supply chain network, and this basically provides a lot of functionalities. But this can also leak privacy, that that specific person who is driving the truck was present at a specific time at that time, at a doing this specific delivery. So this can lead to privacy leakage. So this can be protected in certain manners. So we are working over identifying certain models to protect this up. So the final challenge is like we are our group is designing like privacy preserving smart contracts in a way that we can deploy smart contracts, or we can execute smart contracts for the data analytics, and it does not carry personally identifiable information with itself. So designing private smart contracts is one of the challenge that we are solving. The last one is like privacy issues in blockchain channels, because there are different communication channels that you can say we are like in, let's say, in the hyperledger fabric, there are multiple channels for different type of communication or different type of transmission. So each one has their own specific privacy limitation, privacy issues. So we are working on designing certain privacy models for these type of channels. This is one of the challenge that we are solving. So these are till now certain outcomes, like our articles got published in IEEE Communications Surveys Impact Factor 23.7, and then certain transaction article, IEEE Transaction on Services Computing, and on JPDC. So like these are all the our works that have been published till now, and there are multiple other that are being carried out. So that's all from my side. Thanks so much. And if there's any question, I'll be happy to answer and discuss.